Today I'm going to prove the conductivity equation. The conductivity is equal to the number density times charge of electron squared over mass of electron times the time between one collision. So I'm going to prove this equation. But firstly, we should know that conductivity is a property of a substance. So it's like mass in F equals ma. If you increase the force acting on an object with the mass, its mass will not change. Same as if you increase the acceleration, the mass will not change. It is a property of the object that we're studying. So it doesn't depend on the force nor the acceleration, which is same as how conductivity does not depend on the electric field. So this equation, which is the current density is equal to conductivity times the electric field. So how could I prove that? So let's first rewrite the current density, which could be rewritten as the number density times the charge of the electron times the average drift velocity, which is equal to conductivity times the electric field. So I just rewritten the left side, and we notice that we have this drift velocity here. And remember that drift velocity, we're referring to like the wire and an electron, and it's like bouncing about like from like a bunch of atoms. We could think about the impulse momentum theorem, where the average force times the time of one collision is equal to the change in momentum is equal to mass times velocity. So this change in velocity, its initial velocity is 0, but its final velocity is the drift velocity. So we could really rewrite this change in velocity as the drift velocity, the average drift velocity, and bring down to m, and we keep the time of one collision. But we can also rewrite the average force here as the electric field times charge, and we get this equation. And if we rewrite it by isolating the drift velocity, we get the electric field times charge over mass of electron times time of one collision. So we get this equation for the drift velocity, which we could put back into this equation and substitute it in, and we get number density times charge times electric field times charge over mass of electron times time of one collision is equal to sigma times the electric field. And we see that the electric field cancels out, and we're left with sigma is equal to number density charge squared over mass times the time of one collision, which is the equation we're trying to prove.